Welcome to the DIY Honda Garage channel. The DTC P2182 indicates that the Engine Coolant Temperature (ECT) Sensor 2 is out of the specified voltage range. This diagnostic trouble code is crucial because the ECT sensor helps regulate the engine's performance by providing the Powertrain Control Module (TCM) with vital temperature information. If the ECT sensor operates outside of its designed voltage range, it can lead to inefficient engine performance and increased emissions. The specific role of the ECT sensor is to measure the temperature of the engine coolant, facilitating adjustments in fuel delivery and ignition timing for optimal operation. The sensor's location is typically situated near the engine block or in the engine cooling system. When the sensor sends erratic signals, the PCM records this anomaly and logs the DTC, prompting the need for inspection and troubleshooting. The error associated with DTC P2182 involves the Engine Coolant Temperature (ECT) Sensor 2 and its communication with the Powertrain Control Module (PCM). The ECT Sensor 2 plays a critical role in monitoring the temperature of the engine coolant. It is responsible for sending real-time data to the PCM, which uses this information to optimize engine performance, including fuel delivery and timing adjustments. The PCM is the central unit that processes this data and manages engine operation. Furthermore, external circuits linked to the ECT sensor, including TW2 and SG6, facilitate this communication. If these circuits are damaged or improperly connected, this could lead to incorrect voltage readings, triggering the DTC. The ECT Sensor 2 is usually located near the engine cooling system, securely attached to measure coolant temperature accurately. There are several possible causes that can trigger the DTC P2182. The most common reason is a faulty ECT Sensor 2, which may be unable to provide the PCM with accurate temperature readings due to internal damage or failure. Another potential cause could be a damaged external circuit related to the sensor, including wires or connectors that may have suffered from corrosion, fraying, or disconnection. The integrity of these circuits is vital for ensuring proper electrical communication between the ECT sensor and the PCM. Lastly, the PCM itself may be defective, possibly due to internal malfunctions that prevent it from interpreting sensor data correctly. Proper diagnosis must rule out each of these possibilities to resolve the DTC effectively. The symptoms associated with the DTC P2182 can significantly affect the vehicle's performance. One of the most immediate indicators is the illumination of the check engine light on the dashboard, signaling to the driver that a diagnostic issue has been logged. Additionally, the vehicle may exhibit poor engine performance, including rough idling, stalling, or delayed acceleration, as the engine struggles to operate efficiently without accurate temperature data. This can also lead to increased fuel consumption, as the engine may run richer than necessary, further exacerbating efficiency problems. In some cases, overheating may occur since the PCM cannot respond properly to the actual coolant temperature. The first troubleshooting step involves turning the vehicle to the on mode and checking the ECT Sensor 2 voltage using the HDS diagnostic tool. This test helps establish an initial understanding of whether the sensor is functioning within its normal voltage range. A value less than 0.14 volts or greater than 4.99 volts indicates an abnormality, triggering the need for further diagnosis. Disconnect the ECT Sensor 2 connector prior to testing to ensure accurate readings. It is essential to understand that this initial assessment will guide subsequent troubleshooting steps. If the sensor's output lies within the normal range, The issue may lie elsewhere in the related circuits or PCM. The second troubleshooting step requires disconnecting the ECT Sensor 2 connector and using a jumper wire to connect terminals number 1 and number 2 in the connector. This method validates whether the sensor is functioning correctly by simulating its output. After making the jumper connection, turn the vehicle to the on mode once again. You should measure the ECT Sensor 2 voltage using the HDS tool. A normal voltage reading should be less than 4.99 volts. If the reading remains within the normal range, this indicates that the ECT Sensor 2 may be faulty, necessitating its replacement. However, if the voltage exceeds the expected range, further investigation into the external circuits or the PCM may be required. In the third troubleshooting step, you need to inspect the circuit connections related to the ECT Sensor 2 and ensure that the external circuits known as TW2 and SG6 aren't damaged. Begin by ensuring both the ECT Sensor 2 connector and the PCM connector E are disconnected. This allows for a thorough inspection of the circuit wiring. It is crucial to check for unintentional disconnections, wear, or corrosion along these wires, as such issues can lead to inaccurate signal transmission to the PCM. A successful inspection will reveal continuity with normal resistance levels, indicating there are no short circuits or open wires affecting the sensor's function. Should any abnormalities arise during this inspection, repairs to the circuit will be necessary to resolve the DTC. The final troubleshooting step involves inspecting the PCM if prior tests indicate other components are functioning correctly. Since the PCM is central to interpreting data from the ECT sensor, any internal issues may prevent it from processing this information effectively. To perform this inspection thoroughly, ensure that prior tests have ruled out the possibility of problems with the ECT Sensor 2 and its circuits. If everything else tests normally, it is likely that the PCM is the root cause of the problem. To confirm normal conditions, cross-reference the results from the HDS tool with normal operating specs for the vehicle's system. If the PCM exhibits any irregularities, replacement may be required. After completing repairs or replacements associated with DTC P2182, it is essential to verify that the issue has been resolved. Start this final verification by clearing any existing DTC codes through the HDS diagnostic tool. This step resets the system and prepares it for a fresh evaluation. Next, conduct a test drive of the vehicle, aiming to mimic conditions that previously triggered the DTC. Monitor the vehicle's performance closely during this drive, checking for any recurrence of the check engine light or poor behavior. If everything functions correctly without re-triggering the DTC, it confirms that the repairs were successful. Document the completion of these tests for future reference and maintenance logs. Preventive maintenance is a crucial part of ensuring the longevity and reliability of the engine coolant temperature (ECT) system in Honda vehicles. Regularly inspecting the ECT sensor and its associated wiring can help identify early signs of wear or failure, potentially preventing the emergence of DTCs like P2182. During routine vehicle inspections, include checks for corrosion, physical damage to connectors, and verify that wiring harnesses are secure and intact. Additionally, performing system checks using an HDS tool can provide insights into the sensor's operational health. These proactive measures could significantly reduce the likelihood of sensor inaccuracies and maintain optimal engine performance, ultimately extending the vehicle's lifespan. In summary, DTC P2182 signals an issue with the Engine Coolant Temperature Sensor 2 being out of range, which impacts overall engine performance and efficiency. By thoroughly diagnosing the ECT sensor, its circuit connections, and the powertrain control module, you can identify the underlying problem effectively. Each troubleshooting step is designed to isolate the fault, beginning with assessing the sensor output and concluding with an evaluation of the PCM. Proper diagnostics and timely repairs are essential to rectify the error and prevent recurrence. Incorporating regular maintenance checks can also mitigate risks, ensuring the engine operates smoothly and efficiently over time. Always remember to document your findings and follow prescribed protocols during troubleshooting. Please like and subscribe to the channel. See you next time.